Hi, this is video about capital budgeting. So what is capital budgeting? Capital budgeting is the process of evaluating and selecting long-term investment that are consistent with the firm's goal of maximizing owner's wealth. Firms typically make a variety of long-term investment, but the most common is in fixed assets, which include property, land, plant, and equipment. These assets, often referred to as an earning asset, generally provide the basis for the firm's earnings power and value. Let's discuss about basic terminology in capital budgeting. Independent project versus mutually exclusive project, unlimited funds versus capital rationing, accept-reject approach versus ranking approach. Independent project versus mutually exclusive project. What is independent project? Independent projects are those with cash flows that are unrelated to or independent of one another. That means the acceptance of one project does not eliminate the others from further consideration. For example, a company is considering to start one operation in F&B industry, or operation in banking industry, or operation in tourism industry. So company can start operation in one or more industry because the operation in one industry does not affect the operation in other industry. Mutually exclusive projects are those that have the same function and therefore compete with one another. That's means the acceptance of one eliminates from further consideration all other projects that serve a similar function. For example, a firm in need of increased production capacity by 2,000 units could obtain it by, first one, expanding its plant to produce 2,000 units, or the company can acquiring another company that produce 2,000 units, or the company can contracting with another company that can produce 2,000 units. Clearly, accepting on any one option eliminates the immediate need for either of the others. Let's discuss about unlimited funds versus capital rationing. What is unlimited fund? Unlimited funds, the financial situation in which a firm is able to accept all independent projects that provide an acceptable return. That means the company has no budget limit. Capital rationing is the financial situation in which a firm has only a fixed amount of fund available for capital expenditures and numerous projects compete for this budget. That's when the budget is limited for that company. So what is accept-reject versus ranking approach? So accept-reject approach involves evaluating capital expenditure proposal to determine whether they meet the firm's minimum acceptance criterion. This approach can be used when the firm has unlimited funds, as a preliminary step when evaluating mutually exclusive projects. In these cases, only acceptable projects should be considered. For ranking approach, involve ranking projects on the basis of some pre-required measure, such as the rate of return. The project with the highest return is ranked first, and the project with the lowest return is ranked last. Only acceptable projects should be ranked. Ranking is useful in selecting the best of group of mutually exclusive projects and evaluating projects with a view of capital rationing. Now we will discuss about basic capital budgeting technique. So basic capital budgeting technique, we have 4 types of techniques: payback period, net present value, profitability index, and internal rate of return. So under basic capital budgeting technique, we assume all projects carry similar amount of risk. To discuss about basic capital budgeting technique, we use example from Bennett Company. So Bennett Company is evaluating 2 projects, Project A and Project B, and the required rate of return set by the company is 10%, and this project is mutually exclusive project. Mutually exclusive project means a company can only choose one project. So the company has two proposals here. Project A with initial investment 42,000. Project B, initial investment 45,000. Initial investment means when the company wants to start the project, the company needs to pay 42,000 for project A and 45,000 for project B. And both projects has a duration of 5 years. Project A will generate 14,000 every year, and project B generate cash inflow 28,000 in year 1, 12,000 year 2, and 10,000 from year 3 till year 5. So if we draw the timeline, you can see from this timeline, project A, year 0, negative 42,000, because in year 0, the company needs to pay 42,000 to start the project. And then from year 1 until year 5, the company receive 14,000 every year. For project B, in year 0, the company needs to pay 45,000, so negative 45,000 cash outflow. And then year 1, cash inflow 28,000. Year 2, cash inflow 12,000. Year 3, year 4, and year 5, cash inflow 10,000 every year. So this is the project that this company needs to evaluate. First, we look at payback period. What is payback period? Payback period is the amount of time required for a firm to recover its initial investment in a project as calculated from cash inflows. In the case of annuity, such as Bennett Company's Project A, the payback period can be found by dividing the initial investment by the annual cash inflow. For mixed stream of cash inflow, such as Project B, the yearly cash inflows must be accumulated until the initial investment is recovered. Although popular, the payback period is generally viewed as unsophisticated capital budgeting technique because it does not explicitly consider the time value of money. So how to make investment decision by using payback period? If the payback period is less than maximum acceptable payback period, accept the project. If the payback period is greater than maximum acceptable payback period, reject the project. So now we use Bennett Company examples. So based on payback period analysis, which project should Bennett Company invest? So this is how to calculate payback period for project A, because project A is annuity cash flow project. So the formula is payback period, initial investment divided by annual cash flow. So initial investment is 42,000 divided by annual cash flow 14,000. So the payback period is 3 years. For project B, this is non-annuity cash flow project. Okay, so to calculate payback period for this project, first we need to calculate accumulated cash flow for the project. So for year 1, the cash flow is 28,000, so accumulated cash flow is 28,000. Year 2, the project generate 12,000, so 28,000 plus 12,000, so accumulated cash flow is 40,000. Year 3, 10,000, so 40,000 plus 10,000, accumulated cash flow for year 3 is 50,000. Cash flow for year 4 is 10,000 plus previous accumulated cash flow 50,000. So accumulated cash flow year 4 is 60,000, and year 5 the project generates 10,000. So accumulated cash flow is 70,000. Then we must try to find out in which year the initial investment is recovered. So you can see that the initial investment is 45,000. So it is between year 2 and year 3 because the cost of project is 45,000. So to calculate the payback period, we take year 2, so 2 years, plus initial investment minus accumulated cash flow year 2 because it is between year 2 and year 3, divided by cash flow year 3. So 2 years plus 45,000 minus accumulated cash flow year 2 is 40,000 divided by cash flow year 3 10,000, so you get 2.5 years. Next, we make investment decision. So how to make investment decision? We compare the payback period. So basically in this example, we choose project B because shorter payback period compared to project A. So this is a mutual exclusive project, so we can only accept one project. Next, we will learn how to use financial calculator to calculate net present value and internal rate of return. So this is your financial calculator. So we will use all these buttons. Okay, as usual, CPT is compute or calculate button. For capital budgeting, we will use the CF button. CF means cash flow. And then we have NPV button, that is for net present value. And then we have IRR button, internal rate of return. And then we will use arrow up and down. Arrow up means scroll up. Arrow down means scroll down. Then when we use financial calculator for capital budgeting, you can see on the screen of the calculator CF0, that's mean for initial investment. So we must put initial investment of the project at CF0. You can see a CO1. So CO1 means first cash flow. And then you can see FO1. FO1 means frequency of first cash flow. I will explain how to use CO1 and FO1. Let's move to the next method of capital budgeting, which is net present value. It is a sophisticated capital budgeting technique found by subtracting a project's initial investment from the present value of its cash inflow discounted at a rate equals to the firm's cost of capital. So formula for net present value is present value of cash flow minus initial investment. So how to make investment decision by using net present value? If the net present value is greater than 0, accept the project. If the net present value is less than 0, reject the project. Okay, so we use example from Bennett Company. We have project A and project B. Based on net present value analysis, which project should Bennett Company invest? So this is calculation to solve project A net present value. So before we start the calculation, you need to clear the memory of your financial calculator. So second, reset, enter CEC. That will clear up all the data in your financial calculator. So we have project A, initial investment 42,000. Initial investment means company needs to pay 42,000. That's why we need to put negative sign. So we start press button CF, and then you must key in 42,000, put negative, and then press enter, and then arrow down one time, and then you key in cash flow year 1, 14,000, positive because cash inflow, enter, and then press button down 2 times, and then 14,000 cash flow year 2, enter, button down 2 times, 14,000 year 3, enter, button down, scroll down 2 times, 14,000 year 4, and then enter, button down 2 times, and then year 5, enter, button down 2 times. Okay, so this is you already key in all the data into your financial calculator, and then you press button NPV. So the required rate of return is 10%. So you press 10 and then enter, button down, and then compute. You get the net present value of project 11,071 ringgit and 01 cents. Now we calculate net present value for project B. So first you need to clear up the data of your financial calculator. Second, reset enter CEC, and then you press button CF. Okay, when you press button CF, you need to key in your initial investment. So 45,000 negative, enter, and then you press button down for 1 times. And then you key in cash flow year 1, 28,000, enter, button down 2 times. 12,000, enter, button down 2 times. For cash flow year 2, cash flow year 3, 10,000, enter, button down 2 times. Cash flow year 4, 10,000, enter, button down 2 times. And then cash flow year 5, and 10,000, enter 2 times, and then press button NPV. You key in the required rate of return or cost of capital, 10%, enter, button down, and then SIP compute. You get 10,924 ringgit and 40 cents. Now I'll show you how to use frequency function in the financial calculator. Okay, so if you look at this example, project A, you receive 14,000 for 5 times. Okay, that's mean the first cash flow that you receive is 14,000 and it is for 5 times, for 5 years. So you second, reset enter CEC, clear up the memory in your financial calculator, and then you press button CF, and then 42,000 negative, enter, and then press button 1 only 1 times. Okay, and then you key in the first cash flow that you receive is 14,000, enter, button down 1 times, and then you key in the frequency. If you see at your financial calculator, there is a figure F01. That means it's frequency for cash flow year 1. So you key in 5, enter 1 time, and then press NPV, 10, enter, button down, and then compute. You get the answer 11,071 ringgit and 1 cent. This is your example to calculate net present value for project B by using frequency. So if you see the cash flow of the project, year 3, year 4, and year 5, you receive same amount of cash flow, 10,000 for 3 times. So you can use frequency function for 10,000 cash inflow for 3 times. So first you clear up all the financial calculator, second reset enter CEC, and then you press button CF. So 45,000 negative, enter, button down 1 times. That is for initial investment. And then you have 28,000, enter, button down 2 times. 12,000, enter, button down 2 times. 10,000, enter, button down 1 time because you want to key in the frequency, and then the frequency is 3 times. You press 3 and then enter, and then frequency 1 time. The button down 1 time, and then NPV 10 for required rate of return, enter, and then button down, and then compute. You get 10,924 ringgit and 40 cents. So how to make investment decision? We compare the NPV of the project. So we choose project A because NPV of the project is higher compared to the NPV project B. Next is Profitability Index. So Profitability Index, the formula is total present value of future cash flow divided by initial investment. So if you use financial calculator, you calculate the NPV and then you add up back with the initial investment and then divide by initial investment. So invest in the project when the index is greater than 0. This is an example for company Bennett's company. So based on profitability index, which project should Bennett company invest? First, you need to calculate the net present value. So you already calculate the net present value. So project A, you get 11,071 ringgit and 1 cents. So you plug it into formula profitability index, plus 42,000 divided by 42,000, so you get 1.26, the index. For profitability index project B, the net present value, you get 10,924 ringgit and 40 cents. So plus with 45,000 of the initial investment divided by 45,000 of the initial investment, so you get 1.24. So when you compare the profitability index of project A and project B, so you find out project A is higher than project B, so we should invest in project A because higher profitability index compared to project B. Next is internal rate of return. What is internal rate of return? It is the rate of return that the firm will earn if it invests in the project and receive the given cash inflows. So when IRR is used to make accept-reject decision, the decision criteria as follows. If the IRR is greater than cost of capital or required rate of return, accept the project. If the IRR less than cost of capital or required rate of return, reject the project. So this is example for Bennett Company. So we want to calculate the IRR for Bennett Company project. So to calculate IRR project using financial calculator, first you need to clear up the data in your financial calculator. Second, reset enter CEC and then you press button CF. You key in the initial investment 42,000 negative and then enter, press button down 1 times, and then 14,000, enter, button down 2 times, and then you key in all the cash flow from year 1 until year 5. After you finish enter your financial data into your financial calculator, you press button IRR and then compute, you get 19.86%. Next, you calculate IRR for project B. Second, reset enter CEC. You clear up all the data and then you key in the initial investment and then all the cash flow from year 1 until year 5. After you key in all the cash flow, you press button IRR, compute, you get answer 21.65%. You can also use frequency function for key in the cash flow and then to calculate the IRR. Okay, so you second reset enter CEC, clear up the data and then press button CF and then you key in the initial investment 42,000 negative, enter, and then you press button down 1 times and then you key in the first cash flow which is 14,000, enter, button down 1 times and then you key in 5 for 5 frequency, enter, and then you press button 1 time and then you press button IRR and then CPT. You also get answer 19.86%. Same goes for project B. You can key in using the frequency button for cash flow year 3, year 4 and year 5. You also can get 21.65%. So when you compare the IRR for project A and project B, okay, we can see that the IRR for project B is higher than project A. So we need to invest in project B based on the IRR because project B generate higher rate of return. Now we move to the risk in capital budgeting technique. So the previous method that we have learned, which is the payback period, net present value, internal rate of return, profitability index, all those methods assume every project carries same amount of risk. But in reality, different projects carry different amount of risk. So we need to incorporate risk analysis in capital budgeting. So we can use break-even cash inflow analysis, scenario analysis, or risk-adjusted discount rate analysis. So what is break-even cash inflow analysis? It is the minimum level of cash inflow necessary for a project to be acceptable. When break-even cash inflow is used to make accept-reject decision, the decision criteria are as follows. Project with annual cash flow higher than BCI, accept the project. Project with annual cash flows less than BCI, reject the project. If both projects have annual cash flow higher than BCI, choose project with low risk. That means high probability you can get the expected cash inflow. For example, we can calculate BCI for project A for Bennett Company. Okay, so how to calculate the BCI? Basically, we calculate the PMT of the project. So we press second reset enter CEC, clear up the data. So we know that project A is for 5 years, required rate of return is 10%, and then the initial investment is 42,000. So you key in N equal to 5, IY 10, 42,000 for present value, and then compute PMT. So you get PMT 11,079 ringgit and 49 cents. So you get the PMT, that's mean the minimum amount of cash flow of the project for every year is it should be 11,079 ringgit and 49 cents. So if you compare every year, the project generate 14,000, which is higher than the BCI. So we accept this project because annual cash flow from the project is higher than break-even cash inflow or minimum amount of cash inflow for the project to generate 10% of return. Okay, so this project we should accept. For project B. Project B, if you calculate the BCI, break-even cash inflow, so you second reset enter CEC, clear your financial calculator, and then the project is for 5 years, you press N equal to 5. The required rate of return is 10%, so you press 10 for IY. Initial investment is 45,000, so present value 45,000. Compute PMT, so you get 11,870 ringgit and 89 cents. That's been this to accept this project, the project must generate at least 11,870 ringgit and 89 cents. So you compare with every year cash flow, you can see that we need to reject this project because cash flow year 3, 4, and 5 are less than the BCI amount. Okay, so we need to reject project B. This is another example for application of break-even cash inflow. This is how we incorporate risk analysis into the BCI analysis. Treadwell Tire Company, a tire retailer with a 10% cost of capital, is considering investing in either two mutually exclusive projects, A and B. That means the company can only accept one project because it is a mutually exclusive project. Each requires 10,000 initial investment, and both are expected to provide constant annual cash inflows over their 15 years of period. The probability of a project A and B to get the expected cash inflows are 10% and 65% respectively. Which project should the company invest and why? First, you need to calculate the BCI for project A and project B. So the BCI, to calculate the BCI, okay, so you press second reset enter CEC, the N is 15, IY is 10, present value is 10,000, the initial investment, and then compute PMT, you get 1,314 ringgit 74 cents. So if you compare the probability A is 100%, probability B is 65%. So your decision based on the probability of the cash inflow, investors should invest in project A because lower risk compared to project B. However, the company should look at the cash inflow every year. So if the annual cash flow for project A is higher than 1,314,074 ringgit, then the company should invest in project A. Next is scenario analysis. Scenario analysis is a behavioral approach that uses several possible alternative outcomes to obtain a sense of the variability of returns measured here by NPV. This technique is often useful in getting feel for the variability of return in response to change in the key outcome. In capital budgeting, one of the most common scenario approach is to estimate the NPV associated with pessimistic worst case scenario, most likely, which is the expected cash flow, and optimistic or best scenario for cash flow. The range can be determined by subtracting the pessimistic outcome NPV from the optimistic outcome NPV. So how to make investment decision? So we choose project with NPV positive for all scenario, and then the second one we choose project with small NPV range. For example, we have two projects here, project A and project B. So if you look at the initial investment, both project needs to pay, or you need to prepare initial investment 10,000, and then project A under pessimistic generate 1,500 per year. Project B generate 0 if market is very bad. Most likely means normal market condition. Both project generate 2,000 per year. And for project A, for optimistic or best case scenario, the project will generate 2,500. Project B will generate 4,000. So the range for the cash flow, project A is 1,000, project B is 4,000. So the cost of capital is 10%, period of the project is 15 years. So which project should you choose? So first, you need to calculate NPV for project A for three case scenario, pessimistic, most likely, and optimistic. So we use function frequency. So to key in your financial calculator, second reset enter CEC, and then you press button CF, and then you key in the initial investment 10,000 negative because cash outflow, you need to pay that amount, enter, and then you press button down one time, and then you key in the annual cash flow 1,500, so enter cash button down one time, and then frequency is 15, enter button down one time, and then you press NPV 10, enter button down, and then compute, you get 1409. So you calculate net present value for pessimistic, most likely, and optimistic for project A. Next, you need to calculate the net present value for project B for three market condition, pessimistic, most likely, and optimistic. Okay, you use your financial calculator, and then you can make your scenario analysis. So if you look at the net present value, you have project A and project B. So the range is for project A is 7,606. For project B is 30,242 ringgit. So how to choose your project? First, you must look at NPV for each market condition. So project A, the NPV for pessimistic, most likely, and optimistic, all the figures is positive. But project B, under pessimistic, the net present value is negative. That's mean we need to reject project B. Okay, so the decision accept project A. Why? Because NPV for all scenario are positive, and then you have small NPV range compared to the project B. The next method to incorporate risk in your capital budgeting technique is by using risk-adjusted discount rate. So the rate of return set on each project is based on the risk of each project. Project with a high risk should have high rate of return compared to the project with low risk. The valuation of NPV or IRR of the project must be based on the risk of the project. One of the methods to calculate the required rate of return for the project is by using CAPM. So you have R for return for project equal to risk-free rate plus beta project plus RM minus RF. Okay. So let's say you want to evaluate project A and project B for Bennett Company, but this time you need to calculate the rate of return for each project first, or the target return. So beta for project A is 0.8, beta for project B is 1.5. So to calculate the NPV or IRR, you need to calculate the RADR for both projects. So project A, you plug in the figures into the CAPM formula, so you get the return for project A is 9.6%, and then for project B, the return is 14.5%. After that, use the RADR to calculate the net present value for project A. So if you look at the interest rate here, we use 9.6%. This is basically interest rate RADR that we calculate before. Okay, calculate the net present value for project B. So if you look at the net present value for project B is 14. Okay, you incorporate RADR in IRR analysis. So you calculate the IRR for project A. So IRR is 19.86%. The RADR is 9.6%. So RADR is basically the target return. So the net return for the project is 10.26% for project A. The net return, the IRR from the project is 21.65%. RADR is 14.5%. So your net return is 7.15%. So we can make one table to conclude our investment decision. So you can compare the NPV and then you can compare the net return. So you can see that you need to invest in project A because higher NPV and the net return is higher compared to the project B. Next, valuation of project with unequal period of time. So we use annualized net present value (ANPV) approach. For example, we have two projects here, project X and project Y. Okay, so the initial investment, project X is 70,000, project Y 85,000. The annual cash inflows here. So if you can see that project X is only for 3 years and project Y, the period is 6 years. So which project should you invest if your target return is 10%? Justify your selection. So how to evaluate two projects with different period of time? So we need to use annualized net present value. So how to calculate annualized net present value? You need to calculate the net present value for each project. Okay, so you have project X, so you calculate the net present value. So we use financial calculator, compute net present value, and you get 11,277 ringgit and 24 cents. And then same goes for project Y. You key in all the cash flows related to the project and then you calculate the NPV. You get the NPV for project Y, 19,013 ringgit 27 cents. So that is step number 1. Number 2, you need to convert net present value to annualized net present value. So how to convert NPV to ANPV? Basically, the NPV that you calculate from the step number 1, you put it as a present value and then you compute the PMT. So if you see the example for project X, okay, the N is equal to 3, IY is 10, required rate of return is 10. Net present value from the previous step is 11,277 ringgit 24 cents. So you plug in as a present value and then you compute PMT, you get 4,534 ringgit and 74 cents. And then for project Y, okay, the period is for 6 years, so N is equal to 6, IY equal to 10. The present value is 19,013 ringgit 27 cents. So you compute PMT, so you get 4,365 ringgit 95. So based on annualized net present value, we need to choose to invest in project X because it generates higher ANPV. Next, we move to capital rationing method, IRR approach or NPV approach. Rationing. So firms commonly operate under capital rationing. They have more acceptable independence project that they can fund. In theory, capital rationing should not exist. Firms should accept all projects that have positive NPVs or IRR more than cost of capital. However, in practice, most firms operate under capital rationing. Generally, firms attempt to isolate and select the best acceptable project subject to capital expenditure budget set by the management. The objective of capital rationing is to select a group of projects that provides highest overall net present value and does not require more dollars than are budgeted. So we have two methods for capital rationing. The first one is IRR approach. IRR approach capital rationing that involves graphing project IRR in descending orders against the total dollar investment to determine the group of acceptable project. So we can plot the investment opportunity schedule. So by drawing the investment opportunity schedule, we can select the best project for the company. Okay, Ted Company, a fast-growing plastic company, is confronted with 6 projects competing for a fixed budget of 250,000. The initial investment and the IRR for each project are as follows. So we have project A, B, C, D, E, and F. And you can see the initial investment for each project. Okay, and then the internal rate of return or IRR for the project. Okay, project A initial investment 80,000, IRR 12%, project B 70,000, IRR 20%, project C 100,000, IRR 16%, project D 40,000, IRR 8%, project E 60,000, IRR 15%, and project F 110,000 initial investment, IRR 11%. So the cost of capital for this for the company is 10%. So to draw the investment opportunity schedule, first step you need to rank the project based on IRR. So we rearrange the project based on the IRR. So the highest is project B with IRR 20%. And then followed by project C, IRR 16%, project E, IRR 15%, project A, IRR 12%, project F, IRR 11%, and then project D, IRR 8%. And then you have the initial investment for each project. Then second step, you need to calculate the accumulated initial investment. Okay, so project B, IRR 20%, initial investment 70,000. So accumulated initial investment, project B is 70%. 70,000. And then you have project C. Second project is project C, 16,000. The initial investment is 100,000. 100,000 plus initial investment in project B, you get 170,000 accumulated initial investment. And then you prepare the column accumulated initial investment for the rest of the project. So project E 60,000, so 170,000 accumulated initial investment project B and C plus initial investment in project E 60,000, so you get 230,000. Okay, So after you prepare the column, you can draw the initial investment opportunity schedule, IOS. Okay, so if you look at the IOS line, first we have project B. Project B, the IRR is 20%, and then the total initial investment is 70,000. And then you have project C, the initial investment is 100,000, so 170. So you draw this line, and then you can draw cost of capital for this project is 10%, and then the budget constraint is 250,000. So based on this diagram, you can only invest in project B, C, and E because the total investment in this project is 230,000, and these three projects give you the highest internal rate of return. Next, capital rationing by using NPV approach. An approach of capital rationing that is based on the use of present values to determine the project that will maximize honest wealth. It's implemented by ranking project on the basis of IRR and then evaluating the present values of the benefits from each potential project to determine the combination of project with the highest overall present value. This is the same as maximizing net present value because the entire budget is viewed as the total initial investment. Okay, so we look at the example for TID company. We have project B, C, E, A, F, and D. And this project is already been ranked based on the IRR of the project. So the highest is project B, 20%, and the lowest is project D, 8%. So budget available is 250,000. So you have the initial investment, and then you have the present values of the inflows at 10% there. Okay, so first we need to take out project D because the IRR of project D is lower than the cost of capital for this company, which is 10%. So now we can only consider project B, C, E, A, and F. Okay, so the budget available is only 250,000. Okay, so we reject project D. Then we need to find out which combination of project B, C, E, A, and F that can give the highest NPV to the company. Okay, so we need to select a combination of project with total initial investment less than 250,000 and give highest total NPV. So you need to try and error. Okay, so let's say combination number 1, I choose combination project B, C, and A. So total initial investment is 70,000, project B, project C 100,000, project A 80,000. So the total initial investment is 250,000. So the total present value is project B 112,000, project C 145,000, and project A 100,000. So you get 357,000. So the NPV of the project, you can calculate the NPV of the project. So you get 107,000. Okay, let's try a second combination. Let's say we combine project B, C, and E. So the total initial investment is 230,000, total present value 336,000, and the NPV is 106. So therefore, we choose to invest in project B, C, and A because budget allocation can cover total initial investment, and the combination of NPV generated from project B, C, and A is the highest among the others combination. So that's all for capital budgeting technique. Thank you.